Okay, I think we are on the hour, more or less. As experience tells us, people will continue to trickle in, but it's also good to start on time, nonetheless, not to risk losing time or getting out of time. Good morning, all. My name is Erik Meers from the Ghent University. And today I will be moderating at least the first part because I will also guide you through the program in a minute. And then you will learn that the program this morning has two distinctive parts. But maybe the next slide, yes. Maybe a little bit on the history. The European Sustainable Nutrient Initiative, the ESNI, is an event that was organized some years ago for the first time. It is meant to be an annual event, and under more optimal conditions, we do this physically in Brussels to also relay our project results from the participating projects dealing with nutrients with and to the European Commission. As well as European Association. So that's why we usually take Brussels as the venue for this recurrent event. Of course, Corona has obliged us to switch also towards more digital and online settings. And today is also one of those webinars. And I think in the future, it will be a kind of a mixture of both. In the last year, we had 3 webinars from Esni, and today again it is an online event. In the future, we hope to welcome you back in Brussels, but of course, webinars have also um, have their merit, as we have seen in the past. Maybe first a practical point. So those attending, please turn off cameras to not to absorb our bandwidth. Also turn off your mic to have a smooth running of the event. The event is recorded, so that will also be shared afterwards. And if you have questions, there is also a chat section. You can already write down your questions so that we can come back to it. Either if you have time, sometime directly after the speech of each presentation, or we take them up in the dedicated Q&A sections. For the speakers, if you are running out of time, then you might see my face popping up as I will turn on my camera, and that's already, let's say, a hint that you need to wrap up. But so, like I was saying, the ESNI is a recurrent event. It's an event that is organized from the BioRefine Cluster Europe. And the BioRefine Cluster Europe, if you're not familiar with it, I invite you to go to the website. It's quite easy to remember. It's biorefine.eu. And it's about bringing European projects together in their communication efforts, so to create a greater joint impact. And we do this by means of organizing events such as ESNI, but there is also a monthly bulletin, the BioRefine bulletin, in which you can get a taste of what is new in the different projects. There is also social media, so you can look us up on Twitter or LinkedIn. So there you can find more frequent data and news popping up. So that is yeah, good channels to follow. What else can I say about the BioRefine cluster is that it's working on a broader set of topics. So there are 6 ones, about of which nutrient recycling is one. It's a very important one. As of course, it's also the topic of the ESNI as of today. There are other topics that you might also find interesting in the broader realm of and the broader domain of bioresource recovery that is under the umbrella of the BioRefine cluster. So one final thing about the cluster, it is an open access type of forum. So it means projects can freely join, and it's also a free forum. That means that the project join based on commitment. They do not contribute financially. So it's an open access and free of charge platform that is thriving and driving on commitment of those projects to join forces and having a broader impact on communication. So maybe in the next slide. So the program for today, like I briefly mentioned before, will consist out of two main parts. The first part I will moderate, so that will be on the topic towards the practical implementation of innovative solutions. And in that, we will go through a number of projects. We have ALG-AD lined up, Water to Return, to give some dedicated talks. And then we also have, of course, room for Q&A. Like mentioned, if you already have questions as these presentations are going on, do feel free to already write them down in the chat part, and so that we can take them up. So we have a dedicated Q&A a little bit after 10. Then we have some project pitches for new projects that are starting. And then a very interesting part of this session is we are also launching a community on nutrient recycling, or actually relaunching, because we already had in the past efforts towards this to have a genuine community, the people behind the projects, as it were, dealing with nutrients. But of course, Corona has made that a little bit difficult. And now we are renewing those efforts and strengthening those efforts. And that will be presented by Ana Robles Aguilar and Laia Lienas Argelat. I think I pronounced that name, but mispronounced that name, but I think Laia will forgive me. Then we go into a coffee break, and on the second part, I will hand over the baton, as it were, to the Elisabeth Nadeau from the Rice Foundation, who will then take us towards the farm to fork strategies and how we can reach those in by 2030, and the role of farmers and consumers in that. So, but I think then, without further ado, I think I can move towards introducing the first one. So that's the first session is towards the practical implementation of innovative solutions for nutrient recycling. So that is also important, is that we want to have actually not only research for research, but how can that move towards practical implementation. And one of those projects achieving this, or trying to achieve this, is the ALG-AD project, which is about creating value from waste nutrients by integrating algal and anaerobic digestion technology. So it's linking algae production to the AD plants. And the one who will present that today for us is Florian Fernandez from the Swansea University, who has experience and expertise in micro and macro algae cultivation, and which has enabled her to work on a variety of European and national projects. And as part of the ALG-AD team, she has developed optimization processes for the treatment of digestate, and to use this substrate as a nutrient source for microalgae cultivation at pilot scale and produce valuable ingredients for animal feed. So, Florian, I invite you to turn on the camera and, of course, start the presentation.
Yeah, thank you very much for the introduction, Eric. I think you can see my screen now.
Yes.
Right. So I think that's all good. So I'll be presenting today the ALG-AD project, which has been running for almost 5 years now and is due to be completed at the end of June this year. And as Eric said, the project aimed to create value from waste nutrients by integrating algal production and anaerobic digestion. So I'm going to start by presenting the rationale behind the project, which was the European Nitrate Directive, because at the moment, anaerobic digestion is producing a lot of digestate, which is currently used as a fertilizer for soil and for crop production. However, there is an important issue of runoff of this digestate and nutrients into the soil, creating eutrophication issues, and limiting the amount of digestate that can be used as a fertilizer, meaning that a lot of AD plants, anaerobic digestion plants, end up with excess digestate that they can't get rid of, which is why the ALG-AD project was aiming to use this valuable source of nutrients, notably nitrate, nitrogen and phosphorus to grow microalgae, and then use this biomass for different applications. So the project regroups about 11, 12 partners across Northwest Europe, so between France, Belgium, Germany, and the UK, and it is led by Swansea University. So the project also rests on the concept of circular economy by using digestate produced by different types of waste, from kitchen waste to different types of manures and plant waste, and aims to use this waste to produce microalgae and produce valuable ingredients, notably proteins, lipids, to be incorporated into animal feeds. And the project has been focusing on fish and pig feed trials in the UK and also in France with the Coperl partner. As I say, it has 11 partners across Northwest Europe. And one of the interesting things about the project as well is that all the information produced by the project, so from algal production, digestate treatment, to production of the ingredients and animal feed, all these informations are going to be collided into a decision support tools, which should enable producer or people interested in the technology to figure out what are the investments they need to pump into this type of technology, and what sort of profit they could get out of it, and how much nutrients they would be able to recover from their digestate. And these tools should become available in the next few months. So I'm going to describe a bit more the research of the project. So first, we had to start with treating the digestate, because the issue with digestate is that it has a really dark color, a high dry weight, and even though nitrogen and phosphorus are really useful for microalgae, they still need to be tailored to suit the specific needs of different types of microalgal strains. So to do so, we've mainly looked at membrane filtration to treat the digestate. So that was a physical treatment allowing to remove most of the particles, the colors, and also tweak the concentration of nitrogen and phosphorus. So we had really good results using this technology by recovering almost 95% of nitrogen and phosphorus, meaning that we could tailor the concentration of these two elements to suit the different microalgal strains used in the project. So this work is available in a best practice document, which is available online on the website. And the work was also published in 2020 in the journal Waste Management. So now I'm going to move on to the 3 pilots that we've developed as part of the project, because the aim of the project was also to demonstrate that the technology was suitable for large-scale application. So we built 3 pilots in the UK at the company Langage AD, which was an AD plant. Then in France at the Coperl, which was also an AD plant, and finally in Ghent within the InnoLab facilities. So all the 3 pilots were quite different in terms of construction, volume, but we've also tested different strains. So at Langage in the UK, we've used green algae, so chlorella and Senedesmus, in a 5-ton photobioreactor. So that was the biggest of the 3 pilots. Then in France, we grew the microalgae, so a Nitrate, which is an heterotrophic microalgae, in a 2-ton photobioreactor. So under quite different conditions compared to the green algae. So that was quite interesting to see as well, a comparison of these 2 strains. And then finally in InnoLab, we've also looked at green algae, but this time as a consortium, again in a 2-ton photobioreactor. And the interesting thing as well is that because we were at 3 different AD plants, we were able to test 3 different digestates. So a kitchen waste-based digestate in the UK then a pig manure-based one in France, and finally a plant-based digestate in Belgium. So allowing to collate quite an interesting set of data comparing the performances of these 3 different pilots. So just a few parameters there of how the production took place at these 3 pilots. So different concentrations of digestate as well. So we all use 2.5% of digestate, which seems like quite a small amount when you look at a 5-ton photobioreactor, but actually the aim was to also have a concentration of nitrogen that was not toxic for the microalgae. So we roughly had between 50 and 80 milligrams per liter of nitrogen under ammonia form throughout the 3 pilots. And then we had different harvesting periods as well. So for the green algae, we were harvesting every 7 days and then renewing water and adding new digestate to the pilot facility. But for the Thorstrokitrid, harvest took place every other day because it's a really fast-growing strain that grows heterotrophically. So you need to harvest it quite often to avoid issues of contaminations by bacteria, for example. And then we've also tested different approaches in terms of so heterotrophy for France, but also autotrophy and mixotrophy in the UK. And the mixotrophy part of this production was quite successful because it allowed us to obtain quite a lot of biomass, quite concentrated, and this biomass was able to take on more of the digestate. So actually the 2.5% digestate that we started with in autotrophic mode was actually increased when we were switching to mixotrophy. So that was quite a successful finding. And this research is also published in the journal Bioresource Technology and is also available in our production best practice that is also on the website. But thanks to these 3 pilots, we were able to produce 25 kilos of concentrated biomass for all the different strains, so concentrated at 10 grams per liter. And this biomass was then used for the animal feed trials. But first, we've looked at different ways to downstream process the biomass, because after harvest, you need to dewater the biomass, but also look at different treatments to extract the valuable products that we were able to have from the produced biomass grown on digestate. So the main route that we've explored here was hydrolysis, because it's sort of a cheaper process than more standard extractions, so chemical extractions, for example. But still, it allows to have a better incorporation in feed formulation and by animals in general, in the guts, etc. So we've looked at developing different enzymatic cocktails which were suited to the different strains, because we had different types of algae with different cell walls. So it was important to tailor the enzymatic cocktail to make sure that we could break the cell efficiently and then further down the line break down the bigger metabolites, so proteins, etc., into smaller ones, metabolites, and then for the lipids as well. So we were able to obtain hydrolysate that were then incorporated in our different feed formulation. So we've looked at pig feed trials and fish feed trials. So the pig ones are still being reviewed and data are still being analyzed. So I'm just going to present the 2 fish trials that we did, which was part of our project extension, because at first we were only going to do pig feed trials, but we were able to get a capitalization of the project, allowing us to also look at fish. So we did a sea bass trial in France, where the Thorstrokitrid was used to replace 15% of a standard feed for sea bass juvenile and larvae. And the objective of this was to mainly increase the lipid content of the feed, mainly DHA and EPA, which are very valuable lipids for the aquaculture sector. And then we also did a trial on tilapia, in the UK, and this trial used the biomass of Senedismus obliquus produced at the Langage AD facility, and we've replaced 10% of a standard feed with this hydrolysis. And the objective was to try to decrease the reliance on fish meal proteins, which at the moment come from natural stock, by replacing it with our algae AD biomass. So the main results of this trial, so first the CBAS trial, so this is just a brief overview of the result, and all these results will be available soon, either via a best practice or publication, so just look out for this because there's going to be in the next few months. But briefly here, for the CBAS trial, what we found is that growth was roughly comparable when using a control diet compared to our algae diet using the Fostrokitride in that case. But the interesting result was that there was a better quality of the fish flesh. So mainly in the muscle, we had more DHA, but also in the livers. So that was a very good selling point for the aquaculture sector, because it meant that our feed actually increased the value of the fish in terms of DHA available in the flesh. So then our tilapia trial in the UK. So again, briefly, our main results, we also had a comparable growth, but we looked a bit closely at the quality of the fish, and we mainly looked at the gut microbiome, and we found that there was an increased diversity of the gut microbiome in tilapia fed under algae diet. And a better microbiome diversity also means better fish health and immunity. So that was also a really good selling point for us and for the aquaculture sector, because it meant that potentially our feed could reduce reliance on antibiotics, for example, that can be used extensively in aquaculture. But we also looked qualitatively at the flesh, so again, mainly fatty acids. And we did find quite a lot of different fatty acids, so 22 in total. But what was interesting was that the total fatty acid and PUFAs were significantly higher for the algae feed. And this was mainly explained because in our biomass of Senedismus, we actually had a higher amount of alpha-linoleic acid, which were metabolized in different lipids that we had found in the tilapia flesh. And also we had a better omega-3 to omega-6 ratio, which was nearly 1. And that also shows a really good quality of the flesh in terms of aquaculture and as a improved market value really of the fish. So that was all really positive results, and growth was not necessarily increased by the algae feed, but the quality of the fish and immunity, etc., were improved. So that was a really good result. So briefly, just to wrap up, as I said before, these results are available. Well, have been collided in the algae decision support tool that should be available really soon in the next few weeks. So look out for this on the website, and you'll be able to use this if you want to implement the algae technology at your different facilities. And all of our best practices and deliverables, everything is available on the website, so you can have a look. We also have webinar recordings because we've been doing a few webinars in the past couple of years, so they're always interesting to check. And yeah, thank you very much for your attention. And if you have any questions, you can just contact our communication officer, Ala Silpina. Thank you.
Thank you for the nice presentation. And I think everyone will agree that this, one of the nice things is that this project is moving towards its end. Well, it's not nice because it's ending, but it's nice because it has quite specific output as was presented. It's also nice that it was done at pilot scale level in 3 countries. So a wealth of information available there. I don't think that there are questions at this stage, so people may allow to trickle it in and let it sink in, so they can pose questions and we can come back to them during the Q&A session. So that leaves me then to introduce the next speaker and corresponding project. So Pilar Zapata Aranda will be talking about the Water to Return project, which is about resource-oriented solutions for industrial wastewater treatment. Now, Pilar Zapata Aranda is a senior project manager at Bio Azul. It's a company in the south of Spain and has been working for more than 16 years as project manager. She has extensive experience in proposal writing, negotiation, coordination of research, development, and innovation projects. Has been working in different European programs and dealing with a wide variety of water management, treatment, reuse, waste management, circular economy, resource sustainability, sustainable sanitation, and other environmental issues. So quite at her place within the BioRefine cluster. She has been working on 17 or more than 17 funded projects so far, being either coordinator or administrative coordinator for 10 of those projects in the framework of a variety of European projects. So Pilar, the floor is yours to introduce us and lead us into the Water to Return project.
Thank you very much, Eric, for your presentation, and thanks a lot for inviting us to this event. We are really pleased of that. So I'm sharing my screen. So I would like to talk to you a little bit about our project, Water to Return. And I would like to start giving a little bit of context and for providing some reasons why this project exists, and we decided to work on it because Bio Azul is with water treatment engineering, and we are quite used to work with different kinds of wastewater and different kinds of inputs, and we are quite aware that wastewater is a resource for us because it's absolutely full of nutrients that can be extracted and used for other purposes. And especially the food industry and in the slaughtering sector, the consumption of water and energy is very high, and therefore the production of waste and wastewater is also very high. So we know this is actually a source of a lot of nutrients. And the current approach in reality is basically devoted to treating the water until the limits the legislation permits, and then dispose it without treating it or trying to extract those nutrients. And on the other hand, we are also aware about the agricultural sector and the problems it is facing because it will have to feed an increasing population, which will reach more than 9 billion people by 2050. And it will have to do this dealing with different kinds of problems like more limited rural labor force in a context of climate change, land limitation, and so on. It is very related to this, the fact that the extensive use of chemical fertilizers may damage the environment because of eutrophication, and it is associated with the emissions of greenhouse gases. So it is clear we need to provide an alternative that helps to ameliorate a little bit the situation. So we are talking about two very different sectors, not initially related each other, but there is a link between them because one of them has a lot of nutrients to provide, and the other one needs a source of nutrients to provide agronomic products. So the alternative we have think about is Water to Return project, which faces the environmental and economic constraints of the slaughtering industry for treating their wastewater as a market opportunity to provide different kinds of secondary raw materials to further manufacture agronomic products. It adopts a circular economy approach to extract the maximum value from the slaughterhouse's effluents and it makes possible to recover nutrients and turn them into value-added products for the agricultural sector. So Water to Return, in a nutshell, proposes an integrated solution on the one hand for the slaughterhouse wastewater treatment and recovery nutrients with high market value in the agricultural sector. So it is an approach in which we somehow transform the wastewater treatment installations in the slaughterhouses into biorefineries. It is an innovation action funded by the European Commission under its Horizon 2020 program. It started in July 2017, and it will finalize in 2 days. So it has a 57 months duration. It has a budget of around 7 million euros, from which nearly 6 million are funded by the European Commission. It is coordinated by a sole company, a technology provider in Malaga, in Spain, and it has a consortium of 15 partners from 8 different countries. This is basically the localization of each of them. All of them with different backgrounds and different kinds of entities, universities, companies, etc. So the system itself is divided in 3 different treatment lines plus an energy recovery module. It is organized in cascade in a way that the output of one of the treatment lines constitutes the input of the following treatment line. We have, as mentioned, 3 treatment lines that we have called them water line, sludge line, algae line, and the energy recovery module. So I'm going to explain a little bit one by one. Wastewater comes directly from the slaughterhouse to the water line. In there, we treat this wastewater with an SBR in our case, and then we use a filtration unit composed by microfiltration plus ultrafiltration and reverse osmosis. And in this way, what we do is, on the one hand, obtaining treated water, and on the other hand, a concentrated of nutrients. This concentrated of nutrients constitutes the first secondary raw material with which an agronomic product is manufactured, which is concretely a biofertilizer. In our case, it resulted that the amount of nutrients already in origin from the wastewater of the slaughterhouse was not so high, as high as we expected. So we realized it could be a nice agronomic product, but not really commercial, because we should transport a lot of water to actually manufacture the product, which is not environmentally sustainable enough. So we use this product as a 0 kilometer solution for fertigation of a local field. And from this treatment, we also obtain as a product that initially in common wastewater treatment systems should be disposed, but in our case, it's the input for the next treatment line, which is the sludge line. In this case, we use the sludge resulting from the water treatment, and we upgrade it through a fermentation process with bacillus. So there is a process of sanitization and afterwards the fermentation step. In this case, what we obtain is an hydrolysis sludge, which is the secondary raw material of the project, and from it we produce a biostimulant, which is also an agronomic product. It has been tested in different fields across Europe, and it's providing very good results, because the company within the project working on this, which is called Kimitech, and it's located in Almeria, has been testing this product with others they already commercialized, and they have resulted to be not so far from its performance has not resulted to be so far from the performance of the already commercially available products. It is even better than some of the products they already sell. So we are very happy with this result, and From this hydrolysis sludge, we can use it for producing the biostimulant, but it's also used to feed the energy recovery module. In this case, we upgrade this hydrolysis sludge through an anaerobic digestion process, and we use the biogas produced afterwards for generating electricity. In this case, the CO2 release was initially supposed to be used to feed the algae line. In the end, it has not been possible to use it in this sense. But the algae line, what we do in there is to grow microalgae. It is a Slovenian partner, the one in charge of this treatment line, and the microalgae, which is predominant in our ponds, is Senedesmus. So we feed the microalgae, foster their growth, and this last secondary raw material leads us to the production of another biostimulant. In this case, this biostimulant is also being quite well accepted by the farmers, because in this case it fosters the sprouting and flowering of the trees. We are testing it concretely in apricot, and it is important that flowering occurs more or less at the same time for all branches, because this is a kind of fruit that has to be harvested manually. So if they all flower at the same time, they will all also, the fruits will be ready at the same time as well. So it will be cheaper and easier for the farmers to harvest. And they are very happy with these results, by the way. So what we obtain after the project actually is an integrated treatment system, plus a nutrients and energy recovery system, 3 secondary raw materials, and 3 agronomic products that are ready for commercialization. So it is a new business model based on circular economy approaches and industrial symbiosis schemes. So this provides business opportunities for different sectors: wastewater treatment, energy engineering, manufacturers of fertilizers, biostimulants, etc., slaughtering, and the meat industry. Our demonstrator is located in nearby Seville, in a city called Salteras, and in a real slaughterhouse called Matadero del Sur. It has a treatment capacity of 50 cubic meters per day out of the 150 cubic meters the Matadero actually produces. This is because we are talking about a demonstration project, so we cannot provide, let's say, a real scale solution, but it's easily upscalable if Matadero decides to treat their whole flow. And finally, I would like to share with you some pictures of our system. This is the whole system itself. You can see clearly the algae pond, and then in the background, you can see from the left to the right the water line with the SBR. And in the middle, you can see the blue container corresponds to the sludge line, and then we have there the steel tanks correspond to the energy recovery module. So this is the water line with the SBR, and the filtration unit is in the white part. So this is the sludge line with the fermenter and the other tank for sanitization. The energy line with the anaerobic digester, and the algae line. 2 inoculum ponds and a big pond. And finally, just to wrap up a little bit, again, mentioning that our initial I was going to say early adopters. Early adopters indeed are the slaughterhouses, because it is the place in which we have basically tested the system. So this would be our early adopters, but also the meat processing industry could be a potential client for us. And on the other hand, obviously the agronomic products distributors and the agricultural sector. It is a modular system that can be tailored for future end users, depending on what they want to do afterwards with the treated water, for example, and depending on their expectations, it can be installed completely or just a part of the treatment lines, and it's highly replicable, and it could be adapted to other food industries. So that's all from my side. Thank you very much for your attention.
And thank you also for delivering this nice overview on the water to return project. I have seen no questions. Wait, I see a question in the chat from Marcela de Souza. For the algae biostimulant, do you do any treatment in the algae to break down the cells? Is it commercialized as a liquid or as a powder?
Well, not initially. What we have been doing has been harvesting the algae using a thickener and then a sedimenter, and then we have taken this concentrate of microalgae, and we have used glycerol for conservation. During the trip, let's say to Almeria, and there they have basically used a fibroscreen and then homogenization, and use it in initially liquid. They have used two versions of the product. On the one hand, they have used it liquid in all cases for fertirrigation, and they have also used it for foliar application.
Okay, and then also a question from Elisa Rose, a quite similar question, well, or related question at least, to the one before. How do you market the product? So also Marcela referred to commercialize as liquid or powder, but also Elisa Rose is wondering, how do you market the product, biofertilizer, biostimulant? Do you have any certification, for example, European CE labeled products? Yeah, how is that foreseen?
Mm-hmm. Well, we are not commercializing them yet. We are using them within the project scope with farmers. The company, the partner company in the project knows. We are talking about tests. For certification, the process is quite long yet. The products have the potential to do that, and the company will explore different ways for doing it, because, as you know, it's a long process. They need to certify them for each country and for each product with which they want to use them. So it's foreseen to do it, but at the long term, because it will take quite a lot of time. The certification we have, actually, well, not yet. It's in process as well, because it's part of the project activities. Is environmental technical verification, and in this case, it's done only because it has to be done on innovative processes and technologies. We have used very different kinds of technologies within the project, but many of them are already well known. The innovation here is how we integrate them. But there is a part which is designed by the University of Seville within the sludge line, which is going through this European technical verification. And it deals with the pre-treatment step before fermentation, in which they sanitize and sanitize. It's the same. The sludge. It's called a cascade flush system, and this result this verification will be available soon.
Okay, nice. And also, I think the fertilizing product regulation, which should come in force as of July this year in the different member states, and then of course different certifying bodies and strategies should follow in that slipstream of that regulation. And then I think all of us hope that the process becomes more fluent for all new products to enter the market. And another question from Domingo Francesc. Is it, and it's also a very good question, is it officially usable under organic agricultural production?
Well, that's a tricky question, because with regards to the first biostimulant, the one coming from the sludge line, initially it should be, because it's absolutely sanitized. We have made different kinds of tests, and there is nothing there. But obviously, this is not enough for going through the organic agricultural branch. Let's say it would need several kinds of certifications, and so on. So this is something that the company is also exploring at which point that would be possible. That was the initial idea, but it's being a little bit longer than expected. This exploration, let's say.
Okay. And then actually I have a question for both you and Florian, which is quite similar. I'll start with you, and then Florian can also turn on her camera. It's well, both projects have been investing in demonstration and pilot scale, which is very nice in moving towards the market. Both projects are already in advanced or concluding phases. But what's next? What's beyond the project for these nice installations and pilots? Is there going to be follow-up, or is it going to end at the project ending? Maybe starting with Pilar, and then Florian, you can maybe also touch on the AlkAD pilots.
Well, initially, in our case, the slaughterhouse is very happy with the installation because it actually solves their I was going to say problem. It's not a problem, but it's a need, their need, let's say, about wastewater treatment. And in this case, they are very interested in actually upgrading the plant for treating the whole flow they produce. So what it's basically in their minds right now is, first of all, upgrading the capacity, the treatment capacity. And initially, for sure, we will leave there 2 treatment lines, which will be the water line and the sludge line. And with regards to the others, it's going to be difficult because of we are talking about the real industry, and for them, they do not have people in their staffs able to run all these different kinds of technologies. They are all very, very far from them. And they are especially interested in these first 2 lines, water line and sludge line. The other 2 are more difficult for them to, basically because of staff needed and running afterwards a project. They are more difficult for them.
Okay. And then Florian, about the pilots and activities beyond the project. You're muted.
Yeah, sorry. So some of our facilities, actually, they've been moved away from the AD plants and reinstalled at Swansea. But actually, the pilot, because it was so big, we've actually split it in 2, and an aquaculture company have decided to take over the second part to treat their wastewater from the fish production. So here we've had some like direct uptake actually of the technology by industry. So that was really nice. And then some of the other facilities will remain and keep on using digestate to produce microalgae. So this is carrying on, which is a really good result for us. But actually, as a follow-up, is that we've had a lot of farmers and AD plants really willing to actually use the technology to remediate their waste. So we're looking at having sort of smaller projects to install facilities over there, but actually diversified our activity, because we were looking mainly at digestate, but now we're also going to look more closely at CO2 capture and wastewater remediation. So it's sort of the AlkAD technology is still meant for AD and to remediate digestate, but actually because it worked quite well, we were able to diversify and look at other types of waste with different types of industry, because we have now project with breweries, for example, who are looking at remediate their CO2 using microalgae. So I think that using microalgae for bioremediation is really improving and progressing. The only bottleneck is really sort of larger scale application, because here we had pilot scale, which was already quite big, but to get it to the industrial part with higher TRLs, we really need bigger investment to have way bigger facilities who will be able to remediate higher amounts of waste. So yeah, so that's the only bottleneck. But hopefully, in a few years, once the policies as well have caught on with the technology, we can look at bigger scale applications and get that on track. So yeah.
Okay, that's very good to look forward to. I also know from the Belgian pilot that there are things continuing, and indeed diversification is also key in those approaches. I have also a question popping up on the chat, and this one is for Pilar. It's a legal technical question about the slaughterhouse waste status under the animal byproduct regulation. Is this category 1 or 2, 3? Might be a little bit on the spot.
Yeah.
If you
Yeah, I'm not sure about what to answer to this. I can find out and come back to you, Chris.
Okay, but I think I do not see. I don't think I have any other questions, although there is a question I see here that is not on the screen there. I think it is quite similar. It was also from Elisa Rose. From your experience, what do you think is most important for the actual market implementation and uptake of your products? I think it was, yeah, but maybe both of you could respond, and then I think we need to wrap up and move on to the next part. But maybe indeed, from your experience, what do you think is most important for actual market implementation and uptake of products?
Yeah, for me, I think it's really focusing on higher value products, because then you end up with a product that will have quite a lot of uptake and will generate a lot of profit as well. So it's all about finding a way to produce that cheaper. So using digestate, for example, and then really focus on the higher products and implement that in the industry level. Yeah.
Yeah, I think it's very important to provide alternatives. I mean, farmers are the whole time used to use the products that go well for them, and if we want them to change them by a new one, it obviously has to provide a really good performance, and the price, of course, has to be competitive. So it's very important to actually work on production lines and so on. If we really want to distribute them and be competitive with others in the sector. In our case, as I was mentioning, we have a company already producing this kind of products. So maybe for them, it's a little bit easier to include this kind of new production line and make this kind of convivence between the different in their portfolio of the different products, and offer one and the other and try to make them competitive. But it's true that displacing products already in use, it's complicated. We have to be very competitive in terms of price and obviously performance.
Okay, then one ultimate final question that came in from Christoph Drazaska to Florian. What concentration of nitrogen and phosphorus was reached in the liquid after filtering the AD?
Yeah, so obviously that will depend on the different types of digestate and the waste used as feedstock. But for example, for the language AD digestate, which was kitchen waste, we roughly had still about 2,000 milligrams per liter of nitrogen and probably 700 milligrams per liter of phosphorus. So that meant that the N to P ratio was not great for microalgal cultivation, which is why we've used further treatment, so mainly dilution, which was the reason behind the 2.5% digestate, to bring that nitrogen concentration down and break down a bit more the remaining particles after filtration to release more phosphorus and tweak this N to P ratio for microalgal cultivation.
Okay, I hope that answer was good for Christophe. I think it's also important that to know that it's not only to bioremediate the effluents. It is indeed trying to, let's say, fine tune the concentrations like the NP ratios as to cultivate as much algal biomass as possible. So from the question, I might misinterpret, but it seems like it's about the question by Christophe was how low can you go, but of course the aim here was how optimal can you synchronize nutrients leaving the AD plant and nutrients required in algae production. Okay, but this is a very interesting talk, but of course we need to move on because we do have a program and I'm already lagging behind somewhat. So let's, I will thank again the both speakers, Florian and Pilar. But then moving on to project pitches, we also have three quite recent projects, Ultimate Walnut and Sea2Land, which will also present what they are about so that you can also have them clear on your radar to follow up in for future perspectives. And first up is the yes, the ultimate project indeed by Anne Kleebucker, who is a scientist and a project manager at the Center of Competence for Water in Berlin. She has studied civil engineering, has a PhD in process engineering, and she is a cross-cutting technology group leader for material and energy recovery and two Horizon 2020 projects, NextGen and Ultimate. And in addition, in Ultimate, she coordinates the technological work package with 9 case studies demonstrating and fostering circular economy solutions. So, Anne, I give the floor to you.
Yes, thank you very much. I put my presentation on full screen. Okay, I have to switch it. Oh no.
Well,
Okay,
the screen
here we go.
it's on the screen now.
Now it should be fine, right?
Yes.
Okay, good. So thank you very much for the introduction and welcome to my presentation about Ultimate. Ultimate started 2 years ago, and our goal is to promote, establish, and extend water-smart industrial symbiosis. We develop and demonstrate innovative technologies for those symbioses. We assess the technologies, and we want to develop digital support tools. We also engage stakeholders to discuss our solutions. And finally, we want to develop new business models towards marketability. We are 28 project partners, and KWR is the project coordinator. So how are we going to reach our goals? The idea is that the industrial sector cooperates with the water sector to create a win-win situation for both. As industrial sectors, we have the agri-food, beverage, chemical, and biotech industries. And for the water sector, we have different service providers, such as utilities, specialized small and medium enterprises, and water service providers. We showcase our symbiosis at 9 different case studies distributed across Europe and Israel. And there we demonstrate 37 different technologies. Those technologies are based on circular economy concepts. And for example, for water recycling, we focus on membrane technologies, adsorption technologies, and electrostimulated systems. We recover and reuse different materials like nutrients, sulfur, metals, high added value products, and we also recover energy in the form of biogas and heat, and we want to increase energy efficiency via digitalization. You can find more information about the case studies on our webpage. There you can also find small videos referring to every case study. And you can also find first results, for example, regarding the technology evidence base. This is a project which we do together with two other projects, NextGen and Be Water Smart. And the idea is to establish a kind of Wikipedia for circular economy technologies. It is hosted by Water Europe. You can access it via the link you can see on the screen. And if you are interested in a certain category, you can, for example, click on the material cycle, and then you end up here, where you have a short description about every technology we are investigating in our projects referring to that certain topic. And with this, I would like to thank you for your attention.
And thank you for guiding us through that ultimate project. Moving swiftly on to the next speaker, Francisco Corona, who will be introducing Walnut. If you can turn on your camera, Francisco. And Francisco Corona, it's a very ironic name. It's the good Corona, let's say. Francisco Corona has a PhD in industrial engineering from Valladolid in Spain. Holds a master degree in process and systems research and a master in environment and renewable energies. He has been working in the Fundación Cartif since 2008 as a researcher in the circular economy area, with a focus on wastewater treatment, waste valorization, development of biogas processes, nutrient recovery, process and chemical product optimization, and then pyrolysis and gasification of biomass, and second generation of biofuels, biorefineries, bioethanol, and biodiesel. So it's quite a mouthful. So it's a man of many trades. Today, Francisco will guide us through the Walnut project, which is about closing waste water cycles for nutrient recovery. So Francisco, the floor is yours.
Thank you very much, Eric. Thank you for your nice presentation and for the invitation to the event. And let's go with my presentation. I share the screen. Okay, could you see the presentation?
Yes.
Okay. So let's go. This is a presentation about the Walnut project. The title of the project is Closing Wastewater Cycles for Nutrient Recovery. My brief presentation of myself was carried out by Eric. So in the box of the right, at the right, we can see the general figures of the project, the total budget, the duration, and the call identifier. Okay, this is a summary of the consortium. We are 14 partners from eight countries. Walnut is a research and innovation action. So the consortium is composed by several researchers organizations, industrial companies, SMEs, public institutes, NGOs, and associations. First of all, a quick overview. The wastewater stream I consider a promising resource to mitigate the soil nutrient imbalance, and to recover nutrients from the plant fertilizing process. The nutrients from this large-scale recovery process can be used for bio-based fertilizers, offering a new circular and sustainable model to tackle the limited nutrient mineral reserves and its crucial environmental issues. This is the Walnut ambition. Walnut aims to redesign the value and supply chain of nutrients from wastewater and brine, creating innovative solutions for nutrient recovery while contributing to a circular economy and sustainable in the EU agriculture sector. The objective of Walnut is to close the cycle and migrate from the current linear model of mineral fertilizers production to a circular model of biofertilizers from wastewater. So the objective is analyze inter and intra-regional EU nutrient imbalance, that develop sustainable and resource-efficient technological solutions for nutrient recovery. For sure, the environmental and socioeconomic impact assessment of the proposed solution, and assess the agronomic efficiency of safe biofertilizers, bio-based fertilizers. Okay, in this picture, we can see a general idea of the project. In the first stage of the project, now we are in this step. We will define the current baseline of the nutrient imbalance, the policies, and the farmers and wastewater treatment plant managers' perception. In the next step, we will carry out our laboratory test, okay, to check the feasibility of different nutrient recovery technologies, and we will carry out test inputs with the biofertilizers obtained in this laboratory test. Okay, with this information, we carry out a different pilot plant construction. So we select the most promising technology from the pool tested in large scale, and we construct and operate 5 pilots in different areas of Europe to provide this or to check this to test these pilots or these technologies in a larger scale. And in the same way that lab scale, we test the bio-based fertilizers obtained in this pilot, but in this case in a fuel scale. Okay, with all the information obtained in this task, we carry out an analysis of environmental, economic, social of these solutions, of the solution obtained by the pilot plants. And in the last part of the project, we will develop business models and promote new policies to boost the use of biofertilizers. Okay, concerning the pilots, we have one pilot in the zone of central Spain to treat industrial wastewater, one pilot in Belgium to treat urban wastewater, one in Hungary to treat food wastewater from food source. In Greece, we will construct a pilot to treat brine solution for the demineralization plants. And finally, in the northwest of Spain, we will have a pilot to treat sewage sludge. And that's all. Finally, we have. I have to mention that we have recently launched the project website. We will be updating frequently with the new content, and we have other dissemination channels for the project, such as the Twitter profile, the LinkedIn profile, and for sure the BioRef cluster. So please follow us to be informed about the evolution of the project, and that's all. Thank you very much for your attention.
And also thank you for leading us to that project, the Walnut project. We're looking definitely forward to the results of that. Then next up, the third pitch on the Situland project is by Miriam Pinto Tobalina from the Nijker Institute, where she is a senior researcher. Miriam has a PhD in plant biology and ecology and a master in environment and soil fertility. And at Nijker, her work area is focused on organic waste management and treatment, as well as on sustainable management of agro ecosystems and closing the study of main drivers as climatic change or land use change. She has been responsible for several European projects and national projects related to environmental impact of different forms of agricultural management and new biofertilizer design and production. And now she is also leading the Situland project. So Miriam, the floor is yours.
It's muted.
Yes.
Thank you, Margarita.
Okay.
Okay. Thank you for the presentation and the invitation, of course. Hello, everyone. I have only 5 minutes, so I will try to be very, very brief. And I'm going to give you the main facts of the Situland project. I am going to share the project if I am able, because I'm not used to be able. This is not. This is. Can you see the presentation?
Yes, yes, yes.
Okay. The Stimulant project is a project that we got on May 2020, but due to coronavirus and so on, we decided to start in January of 21. So in this moment, we are with very, very few results. This project, like the others, has a strong reason, that is the Europe's concerns related their dependence of third countries related to the fertilizers production. This dependence reached the 80%. So when as a key sector as agriculture is depending on third countries, you are and now we can see it because of the Ukraine war and so on. We have several problems because we are not able to satisfy our necessities. In this case, we start to work with the fisheries and aquaculture wastes in order to implement new technologies or optimize the existing technologies to obtain the nutrients that until now we were discarded in some way. The project will last 4 years, has 26 partners from 11 countries with a budget of 8.8 million euro. We are going to test 9, I think, to 10 technologies in 7 demonstration pilots that are placed in the more representatives, or one of the more representative fishery areas: North Sea, Baltic, Atlantic, Cantabrian, Mediterranean, and Adriatic. The basis of the project is the regional production of bio-based fertilizers by developing demonstration pilots that can be replicated across Europe, boosting local growth. The idea is to get the wastes that are produced in a particular area, to obtain the fertilizer with the technologies in that area, and to design bio-based fertilizers focused to the crops of that area. So in some way, we want to do small circular models that could be replicated in other areas, in other parts of the world, even. The project consortium has different profiles of institutions and companies. We have 26 parties that representing research organization specializes in valorization of food industry, biotechnology, agronomy, and industries from seafood processing, fertilizers production, byproducts treatments, and so on. In the figure, you can see the countries that are involved in the project. In summary, the project will study different technologies to be applied to byproducts from the fishing and aquaculture industry, from which bio-based fertilizers will be processed with the initial aim of applying them in the local crops and conditions. But the idea is producing as well high-value fertilizers that could be exported in some moment. Besides the effect on soil biodiversity, environmental sustainability, and impact on social parameters and local economy will be studied, and business plans in order to make these things real things will be defined. Finally, bio-based fertilizers from bioproducts will serve to partially replace the imported nutrients for agriculture in Europe, and at the same time contribute to reduce the negative environmental effects of the misuse of these bioproducts and of the environmental effects of fertilizers production, synthesis fertilizers production. Objectives: improve and adapt nutrient recovery technologies to produce bio-based fertilizers, from fish and aquaculture, promote fertilizer production in the European Union from homegrown raw materials, as I said before, based on the circular economy model, contribute to the independence and security of supply of nutrients to European agriculture, reducing the nutrient imbalance in Europe. And these main objectives are divided in several specific objectives that are update and record the intra and inter-regional nutrient imbalance in Europe from aquaculture and fisheries, promote and scale technologies for recovering nutrients from byproducts that will enable Europe to substitute synthesis fertilizers, obtain bio-based fertilizers that ensure crop production and in increasing soil fertility, and optimize greenhouse gas emissions coming from its production, synthesis fertilizer production, assure the soil quality and health, improving its biodiversity and fertility by these new fertilizers, encourage the circular economy and the short chain canals by implementing local and circular business models, establish the correspondence between geographical, climatological, technological, and social conditions and their corresponding business models to design sustainable and circular models based on seed-to-land obtained experience, and raise awareness in society regarding the recovery of byproducts and the use of new bio-based fertilizers and the positive effects on the soil, air, and health. Here you can see the project structure. As you can see, there is six technical work packages. The work package 2 that is focused on assess the nutritional imbalance in European agriculture, and is focused 2 in study the requirements of the different stakeholders involved in the fertilizer world. The work pack 3 and 4 are specifically the work packages that are working in the technological solutions. The work package 3 is mainly focused on fishery industry, while work package 4 is focused on aquaculture industry, and they are developing in this project. In these 2 work packages are the partners that are implementing the different pilots. The technologies that we are testing goes from a very, very well-known compostage or bokashi to more sophisticated ones as freeze concentration, hydrolysis, microalgae growth, and thermomechanical fractionation, and so on. With this bio-base that we are producing in this work package, we will develop the work package 5 that is focused on agronomic studies. The idea is to demonstrate the agronomic efficacy and provide data for modeling and economic studies and life cycles that can also allow us to compare if these new fertilizers are as good or better than the existing ones. In the work package 6, we are going to study the environmental impact on soil biodiversity, on greenhouse gases emissions, and as well if they are innocuous, if they are harmlessness to human health and environment. And the work package 7, we will realize the life cycle of social, environmental, and economical of those bio-based fertilizers obtained. And finally, in the work package 8, we'll focus on the development of the business plans for its condition, its technology, its area, trying to develop a methodology to be able to replicate those models in different parts of Europe and in the world at the end. Of course, there are the general ones: coordination, dissemination, and ethics. And that's all from my side. This here you have the partners that are working on C2 project as well as the web page. And here my contact if you have any question, doubt, or you want to exchange anything. Thank you very much.
Okay, thank you also for introducing the C2 project to us. Looking forward to the results of that project as well. Swiftly moving on because I am lagging behind a little bit in time. But it's a topic that's very interesting and will be introduced by Ana Robles Aguilar and Laia Llenas Laget, and probably again mispronounced. But Ana Robles is has a PhD degree from the Bonn University and has been since 2019 been working in our team in Ghent University, leading the charge on phosphorus research in our lab, in which she also has guided and as several PhDs and master students. Now she has a broad scientific knowledge on nutrient recovery and plant rhizosphere soil interactions, and on top of the research leadership on the phosphorus in our team, she also has been coordinating the international thematic network resource.bio, which has a main objective to promote scientific exchange in the area of bioresource recovery and to develop joint PhDs between the associated partners over the last few years. And then I will also, of course, introduce Dr. Laia Llenas, is a chemical engineer holding a PhD in chemical engineering. She is the Deputy Director of the Beta Technological Center at the University of Vic in Central University of Catalonia in Spain. Has a strong experience in waste and wastewater treatment and valorization technologies, mainly focused on nutrient recovery from different waste streams. And Dr. Llenas counts on extensive knowledge and expertise in the area of EU funding and project management, mainly in projects related with circular economy and nutrient management. And today they will be launching or relaunching or boosting the community on nutrient recycling. So I'll hand the floor to Anna, I assume, first, because she has turned her camera on. The floor is yours.
Okay. I think I will do the presentation in this case, but Anna, just intervene when you want. Can you see my presentation? Can you see the screen?
Indeed,
Yes.
indeed we can.
Yes, great. So thank you, Eric, for the introduction. And I'm here, as you said, with Dana, but I will be doing the presentation today. So I would like to present a joint initiative that we have been working together, the Horizon 2020 project Fertimanure, which I'm coordinating, and the BioRefine Cluster Europe. This is a joint initiative that we started some months ago, and it's about the nutrient recycling community. Eric, in the beginning of the Esni conference, have already introduced the BioRefine Cluster Europe, so I don't think there's a need to spend time explaining again the objective of BioRefine Cluster, but I will give you a very short overview of the Fertimanure project, which started in January 2020, so we are now more or less in the middle of our project. And in this project, we are aiming to develop, integrate, test, and validate new nutrient management strategies to efficiently recover nutrients and other relevant products with agronomic value from animal manure to obtain reliable and safe fertilizers that can compete in the European fertilizers market. So in Fertimanure, we have 5 different on-farm pilots for nutrient recovery from animal manure. We are producing a total of 19 different bio-based fertilizers. We are also working in the formulation and development of tailor-made fertilizers, and for that we have created an online tool to formulate specifically tailor-made fertilizers. And we will also be working in developing new business models, targeting farmers and also the fertilizer industry. That's very briefly about Fertimanure. But today I'm here to present you this initiative. So we are now relaunching a community group called Nutrient Recycling Community. And in order to organize different activities and interactions among different BioRefine Cluster Europe members, And what we are aiming is to foster collaboration with relevant initiatives and projects in Europe related with nutrient recycling and be a platform to exchange knowledge and good practices. So as more specific objective with this community, we want to cluster projects working on the same topic. We want to identify common challenges and needs in the field of nutrient recycling. We also want to share and exchange knowledge to move towards common methodologies and approaches, because sometimes projects are working on their own and we are doing very similar things, but in a different way. So we believe that we join forces and we know what the others are doing and we work together, we will be more efficient and we will have also more impact. That's what also the Commission is looking for. But apart from this knowledge and experience exchange, we also would like to promote joint experiments, joint publications, promote the preparation of new projects, and also see if we can do some staff exchange through secondments or other activities. So in order to better focus and be more productive, what we have done is to divide the activities and events that will be organized under this community in 5 different subtopics. So we have divided it with the first subgroup of technologies for nutrient recovery. Second group will be focusing on the agronomic performance of the fertilizing products. Third group is focused on the sustainability assessment, so life cycle assessment, life cycle costing, and the methodologies for doing this sustainability evaluation. Another group will be focusing on the business models and all the exploitation part of our products, of the bio-based fertilizers, but also of the technologies that are used for that. And the 5th one, we think it's also important to consider policies. So there will be a group working on policies and to see how we can have an impact on regulation. So we have already identified some leading projects that will lead these subgroups. And at this moment, we will have Fertimanure as the leading project of the subgroup focusing on technologies. We will have Lex4Bio leading the agronomic performance part. Regarding the sustainability assessment, it will be Novafert, the project leading this one. Maybe you don't know Novafert yet, but it's a new coordination and support action funded under Horizon Europe and is coordinated by University of Ghent. And in fact, this CSA is willing to look to common methodologies for life cycle assessment. So I think it's a relevant project to lead these subgroup activities. Then for the new business models, we still do not have a leading project, but hopefully we will find it soon, as soon as the community starts. And then for the policy working group, it will be Nutri2Cycle, the project leading it. And I have highlighted in black the 3 of the groups, and this is because we will be starting the activities of the community with these 3 groups. So we didn't want to start the activities considering the 5 groups, but it will be the technology, sustainability, and policies, the first groups starting their activities, and I will explain you later which are the first plans. So going in more detail to specific activities that we will organize under the framework of this nutrient recycling community. So one type of activities will be the online technical webinars. This will include the specific presentations made by the projects that will be participating in the community. And this way we will know better what each project is doing in the specific topics. Other type of activities will be thematic expert workshops and roundtables. These will be mainly face-to-face activities and will be consisting on more deeper discussions on specific topics, on specific challenges to discuss together with the projects participating different topics of interest. Then we will be also organizing events with relevant stakeholders. So in this case, we will be inviting in our activities policymakers, different companies, clusters that can also provide us feedback on what we are doing and to listen to their experience and to also gather relevant information for the activities of the community. We will be also aware and cooperating in different relevant events that will be ongoing. This will include events organized for the European Sustainable Phosphorus Platform or organized by the BioRefine Cluster Europe, Also, the events organized by the different projects, because we will be happy to see how we can be involved there also. And then different type of activities will be to organize, for example, training activities for PhD students, so summer schools or specific webinars for PhDs. And we are also thinking to establish an online platform for information exchange, so we can, in order that projects can publish their job offers, or if they are searching for a specific partners for a project proposal, or if they want to share specific information from their projects, or they want to just leave there some questions that has to be answered. And these are examples of the activities that we are willing to organize. How we will be organized as a community. So first thing is are you participating in a project related to nutrient recycling that is part of the BioRefine Cluster Europe? So if this is the case and you are interested in joining the community, so you will have to decide who will be the main contact for your project. This main contact will be attending the General Assembly of the community that will be formed by a representative of each project, and we will be explaining there the objectives for the following year. We will take some decisions on the activities, and this will be like a general meeting of the community. And then each project will be able to have as many technical contacts as they want in one or in different technical subgroups. And then these contacts, these people will be the one involved in the activities that we will be organizing. Also, as an example, so we already started some activities during the last year, 2021, and this was in relation to the policy part. So we started what we call the Policy Working Group on Nutrient Recycling, and this was an initiative made by Systemic, Fertimanure, Lex4Bio, and Nutri2Cycle projects. And within this policy working group, we wanted to identify opportunities based on strategic challenges, identify possible hotspots in terms of regulation and legislation, to capitalize the results obtained in the projects, and to work together in obtaining policy relevant information to produce together position papers, policy papers, etc. And the idea is that all what we started with this policy working group can be now continue in the subgroup of policies in the nutrient recycling community, because we believe that it will have more impact and it makes sense to join these initiatives. And to finish, as I already mentioned, so we are already organizing some activities to start with this community. So as I said, we will be starting with technology, sustainability, and policy subgroups. And here you have dates for first webinars on these thematics. So for the technologies, we will be organizing a webinar the 29th of April. For sustainability, it will be the 6th of May. And finally, for the policy working group, the 15th of June. The hour will be all of them at 2 o'clock Central European time. And in the aim of these webinars will be that each project that have shown interest to be joining the community in these subgroups can present what they are doing in these fields. And this way we start knowing each other. And also, we will also be, and we hope also to meet you in some of events that are already foreseen in the following month. So it will be Manu Resource in May in the Netherlands, the BioRefine Cluster Europe event in Ghent at the end of May, and also the ESPC4 and PERM in Vienna, organized by the ESPP. And also we will be linked with some webinars that are organized by the Nutri2Cycle Consortium that are intended to present the lighthouse prototypes of nutrient management approaches and innovations. So we will also be involved on that. And in case that you and your projects are interested to join this community, please contact us. You can contact Margarita, Anna, or myself. And thank you very much. And Anna, if you want to add anything, feel free to do that.
No, I don't think she. No, okay, okay.
It's all clear. Thank you,
It's
Lara.
all good. Yeah, I think it was indeed clear. I saw some questions passing by in the chat, but one was both directed to me and Laia, so I took the liberty to answering. It was related to the Nutri Budget project, which is starting in autumn, whether it would also join the cluster, biorefined cluster, and the community. And the answer, of course, is yes to both on those accounts.
Maybe Eric, you can just mention that any project that it's not yet in the biorefined cluster can join for sure for free, just based on commitment. Yeah.
Yes, indeed. It's I touched that in the introduction earlier this morning, but for those who did not see, or maybe it was passed over quickly, but the biorefined cluster is indeed, it's an open access and free of charge forum for projects dealing with any of the 6 topics on bioresource recovery that we have. Well, you can also check out the Biorefine website, biorefine.eu, where we have the 6 topics lined up. Of course, one of those 6 is nutrient recycling. It's one of the spear points of the Biorefine cluster Europe. And projects that are not member yet, they can contact us and they can join, like I said, free of charge. It's open access. The only thing that we ask is commitment, indeed, to exchange on things that are new on the project, so that we can replicate that in the social media, in the bulletins, and so on, and of course to have an active participation as much as possible in the events and so on. Not sure whether there are other questions at this point. I see Chris. Well, there is the chat is going on the Nutri budget. Chris, Nutri budget. There is no link yet because the project was approved recently. We are now going through the setting up the project, and it will launch only in autumn. So there is no link yet. And for your information, Chris, a lot of partners here today are part of that. It is coordinated from Ghent University, in which 3 groups, including my own, are involved from Ghent. But then we also have partners throughout Europe, as is of course common in these projects. Okay, I think that if there are no further questions, then I think should move to the coffee break. And well, we have been lagging behind a little bit, so I would like to reduce the coffee break to about 5-7ish minutes. Let's say that we start again with the second session at 11:15. If that is also okay for the second session moderator, I think, well, let's keep it at 11:15. That's a good round number. So, and maybe Margarita, you can put on the slide of the coffee break, that if people are tuning in now, indeed, that they know that we have not gone away, but we have just taken a little pause. Okay, so let's kick off with the second session of today's Esni event, which will be about achieving the Farm to Fork's 50% reduction in nutrient losses by 2030 target, and the role that farmers and consumers can play in that. Now, the second session in the Esni program for today will be moderated by Elisabeth Nadeu from the RISE Foundation in Brussels. And Elisabeth is an environmental scientist with a PhD in geosciences. She is the main researcher at the RISE Foundation and has co-authored a report on livestock, nutrients, crop protection in the EU with recommendations for policymakers. She also manages the website and social media for the foundation and leads the communication and dissemination work packages for the Horizon 2020 project Circular Agronomics. Elisabeth, I gladly hand over the baton for the second session moderation over to you.
Thank you, Eric. And welcome everyone to the second part of the Esni conference, which is organized by the Circular Agronomics project. The topic for discussion over the next hour and a half will be the farm to fork objectives set for nutrients. We will explore ways in which these can be achieved and learn about the implications for farmers and consumers. So as you can see on the agenda, we will first hear from the Farm to Fork strategy and its objectives from the European Commission. And then we will have presentations from 4 different projects funded under the Horizon 2020 program, all of which are working to reduce nutrient losses in agriculture, as well as reducing the use of non-renewable mineral fertilizers by developing alternatives from manure and waste streams. After that, we will have a short Q&A session. And I already invite you to write down any questions in the chat during the course of the session if you want to address it particularly to somebody at the name at the beginning of the question. So I will now leave the floor to Wim de Beukelen. Wim is a policy officer at DG Sante of the European Commission. He's currently involved in the Farm to Fork strategy, but he has also worked among several other topics on the implementation of the Nitrates Directive, precisely on the evaluation of the programs prepared by the member states, the nitrates reporting, as well as the managing of the activities related with the safe use of processed manure above the thresholds established for the nitrate vulnerable zones. So Wim's expertise fits very well with the topics that we are addressing today, and we're really happy that he could join us. So thank you, Wim, and you can start whenever you're ready.
Okay, thank you. I'm going to start by uploading my presentation. So if you can confirm that it is available. Can you confirm that my presentation?
Yes, we can see it here.
Yes.
Okay, very good. So first of all, thank you very much for this opportunity, and I would dare to say it's good to be back with you all. I have been participating to this initiative already at earlier occasions, and indeed I have now a new hat, which is in fact the implementation or relates to the implementation of the Farm to Fork strategy, and in particular, I am now working on a legislative initiative for a framework for the Union Sustainable Food System. So, and I'm going to briefly explain what this is about and then come back to the nutrient aspects. So the goal of this strategy, of the Farm to Fork strategy, is to adopt a comprehensive Farm to Fork strategy for a healthy and environmentally food system that would build on sustainable food value chain to ensure sustainable food production, and to stimulate sustainable food processing, wholesale, retail, hospitality, and food service practices. We would also promote sustainable consumption and facilitate a shift to healthy and sustainable diets. One of the objectives is also to reduce food loss and food waste and to ensure food security and combat food fraud. In order to enable this transition, the Commission will stimulate and foster research and innovation, and also create advisory services, will collect data and provide skills. Commission also intends to promote the global transition and to ensure a coherent global EU policy, and a global EU food policy. So the Farm to Fork strategy contains 27 different actions. One of the actions concern new legislative proposals. It also foresees revisions of current legislation, for instance, the revision of the consumer information, the labeling legislation, also a revision of legislation under the Plant Protection Products Framework, animal welfare, feed additives, and so on. So there will also be non-legislative actions, such as, for instance, the Code of Conduct for Responsible Business and Marketing Conduct in the food supply chain. So this, why a new framework legislation on a sustainable food system? It is that because currently there is no dedicated EU framework law on food sustainability, similar to the EU framework law on food and feed safety. There are different pieces of legislation that address some components of the food sustainability, such as the pesticides, the GMOs, food waste legislation, the common agriculture and common fishery policies, also legislation on plant reproductive materials and so on, but there is no holistic approach. There was a fitness check of the general food law in 2018, and in fact the conclusion was that it is fit for its purpose, namely to provide safe food and feed in the EU. However, it does inadequately address the new challenges as regards food sustainability. So the objective of the Union intervention would be to ensure that all foods placed on the EU market increasingly become sustainable through a socially responsible food value chain. It would include an enabling environment for future policy and legislation, ensuring coherence with all food-related policies in terms of sustainability objectives. It would also create a favorable and transparent food environment, making it easier to choose healthy and sustainable diets. And it also aims at optimizing the production, distribution, and consumption of food in order to increase resource efficiency and reduce food loss and food waste. The approaches, there are several approaches that we are considering. It would be like we do nothing, so which is the baseline, but I think in the current situation that would not be sufficient. Another option would be to work with voluntary approaches, such as the Code of Conduct for Responsible Business and Marketing. For instance, this is mainly a code of conduct for, let's say, the food processing, but also, for instance, the input to our companies or organizations providing input to the food system can also participate. For instance, there are also fertilizers or producers of fertilizers who are complying or who also have introduced, who are participating to the code. Another option is to reinforce existing legislation, so to review the existing legislation and where needed, reinforce it. Or, and that is the option which is in fact a preferred option for the Commission, is to create a comprehensive framework legislation on the sustainability of the Union food system. There would be several building blocks in that framework, which we would start with. It would include definitions of what is a food system, what is a sustainable food system, what is the food environment, who are the food system actors. It would include also the need for, or the definition of sustainability analysis, what are healthy and sustainable diets, and it would also define traceability for sustainability purposes. There would be minimum standards for foods and food operations. There would be also requirements of responsibilities for the food system actors. There will be horizontal elements for sustainability analysis for regulated products in the food chain. It would include requirements for labeling, criteria, minimum mandatory criteria for public procurements. It would include also government systems, also requirements for transparency and the need for consultation. There will be actions, or we would foresee actions to mitigate negative impacts for the transition of the food system. And also, maybe certainly not last but not least, there will be systems for monitoring towards monitoring the transition towards a sustainable sustainability. So what will we do? We would cut out, let's say, operations that are not sustainable, and we would, by introducing minimum mandatory requirements, so that what we call the push options, things which are not sustainable, would be pushed away, while on the other hand, we would encourage and develop more sustainable foods and food operations by, for instance, supporting innovation, by supporting innovative voluntary initiatives, and also by, for instance, setting criteria for public procurement, where sustainability would then be introduced in the tenders for public procurement in schools and public institutions. On this, we have done already an Inception impact assessment about our initiative, to which several, that was done in September, October. So the initiative was there announced, and we have received feedback from business associations, NGOs, and also from member states. Member states in particular, they draw the importance to the impact assessment, while business operators would mainly focus or would be more inclined for voluntary measures and where needed to reinforce legislation. Of course, business operators raise the issue of the impact of the transition to sustainability on cost and prices and the need for support measures. As regards the NGOs, which also include consumer and environmental organizations, they are very supportive for the establishment of a comprehensive framework legislation, and they emphasize the role of sustainable public procurement, the importance of labeling, and the need for transition toward plant-based diets, towards more plant-based diets. This we will continue with our work on this. The next steps will be the impact assessment, for which, as of April, there will be an open public consultation with a public questionnaire about the several aspects related to the sustainability of the food system. We will also organize targeted expert workshops, consultation with member states, with the parliaments, with the committees, and so on. There is every year we have an annual conference for the annual Farm to Fork conference. Adoption of the framework legislation is foreseen by the end of next year. Now, as regards nutrients, indeed, in the Farm to Fork strategy, it was explained that the excess of nutrients, and in particular the nitrogen and phosphorus in the environment, stemming from the excess use and the fact that not all nutrients are used in agriculture or effectively absorbed by plants, is a major source of air, soil, and water pollution, and also has impacts on the climate. It reduces biodiversity in rivers, lakes, wetlands, and sea. The Commission therefore announced that it will act to reduce nutrient losses by 50% while ensuring that there is no deterioration in soil fertility. So this reduction of nutrient losses will then lead to a reduction of the use of about 20% by 2030. But I think this is quite and very well known to you, this announcement. So what are the issues with nutrients? Also, I guess that you are very much aware of this, so that the nitrogen and the phosphorus surplus into the environment are exceeding the safe planetary boundaries, for nitrogen by a factor 3.3 and for phosphorus by a factor 2. Also, the latest Nitrate Directive reports concluded that 36% of the rivers, 31% of the lakes, and 81% of marine waters have been reported as eutrophic due to the presence of nutrients. So the deposition of atmospheric emissions from the use of fertilizers or related to agriculture production and also from other sources lead to soil acidification and eutrophication affecting biodiversity. So these atmospheric emissions of nutrient pollutants from agriculture and from fossil soil combustion are estimated to be annually responsible for let's say about 40 million premature deaths in the European Union. Nitrogen oxide also is an important greenhouse with 300 times more powerful than CO2 regarding global warming potential, and then also important is that the production of chemical fertilizers consumes about 1 to 2% of the total energy produced in the EU, also leading to CO2 emissions. So what is the Commission now going to do about this? And that was also announced in the Farm to Fork strategy. The Commission will develop with the Member States an integrated nutrient management action plan to address the nutrient pollution at source and to increase the sustainability of the livestock sector. The integrated nutrient management plan will look at the entire nitrogen and phosphorus cycles, including all relevant sources of pollution from agriculture, but also from industry, urban pollution, waste, and energy and transport. It will identify policy gaps of pollution through the nutrient cycles and develop a framework for action that need to be taken at the relevant levels in order to achieve the objectives of the Green Deal. For this, there will be a call for evidence about this integrated nutrient management plan, which will be published very soon, and to which, in fact, the views of stakeholders and citizens will be requested to be provided. What the Commission furthermore will do, it is looking at what is currently known as regards the different sources of nutrient pollution. It will also look at what are the current rules, what is regulated, what is the knowledge, what are the data gaps, and what would then be needed to reach this 50% reduction. Now, I'm going to put on back my hat as being responsible now for the let's say the more general for all the whole food chain. And I think what is important also to bear in mind, and that is that over time the Nitrates Directive exists already for 32 years. Other directives such as the industrial emission directives, the national emission directives and things like that already exist for a while. And what we see is that despite the efforts that have already been done, that there might be a need also to move to a more plant-based diets with less red and processed meat and with more fruit and vegetables that will reduce not only the risk of life-threatening diseases, but also the environmental impact of the food system. This is a quote, by the way, from the Farm to Fork strategy. Also, the European Nitrogen Assessment report also concluded that agricultural activity may decrease strongly if the European population adopts a healthier low-meat diet, leading to lower nitrogen losses related to animal husbandry, but changes to a healthy diet across the EU, which consists of 63% less meat and eggs, would reduce ammonia emissions from animal production by 48%. So this being said, I just wanted to say that yes, many efforts can be done. Many efforts can be done for nutrient recycling and things like that. But in order to achieve the goals of the Farm to Fork strategy, namely to achieve this 50% nutrient losses, more efforts may be needed than only, let's say, a better or more improved recycling of nutrients. So thank you very much for your attention.
Thank you, Wim. Those were very interesting points. Actually, today we are talking about the farmers, but also about the consumers, because as you say, there's a role for both ends here to reduce the nutrient emissions. So now we will, I'll keep the questions for later because we're already running a bit late. But now we will start with the project presentations. First will be Circular Agronomics. This project started in 2018 and will run until mid-23. The project proposes solutions to increase the circularity of nutrients and carbon in agriculture, contributing to a more circular and zero waste society. This is done in the project by increasing the efficiency in nutrient use in the farms and also by recovering and reusing nutrients from waste streams. And with these measures, Circular Agronomics aims to reduce nutrient and carbon emissions to air and water, while at the same time reducing the dependency on the mineral fertilizers. So speaking for Circular Agronomics will be Sinead McCarthy and Jane Callas. First will be Sinead. Sinead holds a PhD in public health nutrition and is responsible for leading Chagas's research program regarding consumer food behavior, health and sustainability in Ireland. She is also a member of the Food Safety Authority of Ireland, contributing to Ireland's food policy issues. So Sinead, the floor is yours. Oh, sorry, I will go ahead and present also Zane, because I understand that you will just follow, one will follow the other. So after Sinead, actually Zane, also from Circular Ergonomics, will present, and Zane is a professor at the Barcelona School of Agri-Food and Biosystems Engineering of the Polytechnical University of Catalonia, and is also the scientific director at the Center for Research in Economics and Agribusiness Development. His teaching focuses on agricultural markets, food marketing, agribusiness and environmental economics, and he's also very active in consumer behavior studies in relation to food. So now, without further ado, I leave the floor to both of you. First, Sinead.
Thanks, Elizabeth. Sorry, I was very eager jumping in with my presentation, and I think I may have cut off your presentation. I was conscious of not wasting any time. I'll assume everybody can see my presentation unless you all start shouting at me. Thank you for the introduction, Elizabeth. So today I'm talking about the Circular Ergonomics project that both Zane and myself work on, along with our other colleagues listed here. And we're looking at both farmer adoption of technology as well as consumer acceptance of more sustainable products. And I'll discuss the consumer acceptance part, and then Zane will discuss the farmer adoption. Just to give you a small bit of background to the Circular Agronomics project, the overall aim of the project is to find effective solutions to improve nutrient efficiency, as is the case with many of the projects here today. And at the same time addressing the social, political and economic dimensions of these solutions. And that's where our work package comes in, and that we're looking at the social dimensions of the solutions. So what we hope to achieve within the Circular Agronomics project is to facilitate the development towards smart, sustainable, resilient and inclusive economies that are part of the circular and zero waste societies. So all of the project details and dissemination activities from the project are all facilitated by RISE for dissemination and can be accessed at the Circular Ergonomics website as outlined below. So more specifically, within work package 4 of Circular Agronomics, we have the farmer survey and the consumer survey. And the background to this has been very much highlighted in the earlier presentation by Wim, and looking at the European Green Deal and the very ambitious targets within this particular deal as well, to move towards more sustainable farming and more sustainable diets. And then try to understand what's important in terms of these policies is understanding the factors that will influence acceptance of technologies by farmers and acceptance of sustainable foods by consumers. So by understanding what factors or facilitate or what barriers are present to either the adoption by farmers or the uptake and acceptance by consumers, we can develop more effective and more targeted strategies. And then we can also use the information gathered in the research to inform evidence-based policies. So by having the consumer understanding and the farmer understanding embedded in the policies, the likelihood for success increases. So moving specifically to the consumer survey itself, the survey was designed based on the theory of planned behaviour. so that attitudes to a particular behavior, the subjective norms and social norms surrounding that behavior, and our perceived control that we have over the particular behavior influences our intentions to perform that behavior and subsequently the actual behavior itself. So we have been looking at this in terms of the attitudes and intentions and behaviors for organic food consumption, for sustainable food choice, and for reduction of food waste. What we've also looked at as well is the willingness to pay for different production methods, such as conventional production methods, organic production methods, and then what we're calling circular or more sustainable production methods. So they're not quite conventional and they're not quite organic, but they are more sustainable than the conventional ones. And then to see if the location, the country of origin, if you like, of the food has any influence, be it European, national, or outside the EU, and then whether there is a certification for the sustainable products or a certification for the organic products. And we're using a conjoint type approach to identify the importance of these attributes and then the willingness to pay and how much people would be willing to, consumers would be willing to pay. So the data has just been collected in 5 countries with 1,000 consumers in each country, and the data collection was completed in March this year. So we have only just begun to analyze the 5 country data. So for the purpose of today's presentation, what I'm showing you is the findings from the pilot survey that was conducted in Ireland last summer on 400 consumers. And we used this survey to refine the questions for the 5 country European survey. So the results of the 5 country European survey will be on the Circular Agronomics website towards the end of this year or during the summer. So looking specifically at the organic purchasing behaviour and the food waste behaviour, what we did find when we applied the theory of planned behaviour was that the attitudes we hold towards organic food was very important in predicting our purchase to our intention to purchase organic food. Social norms were especially important. So if those people around us and the important peers in our life were purchasing organic food, we too were more likely to do it. And then also behavioral control. So knowing that I can go to the shop in the morning or the retail outlet that I go to, and there will be organic food there for me to purchase. And that's really important, or knowing what outlet I need to go to if I wish to purchase organic food. What was somewhat surprising was that the general socio-demographic factors that we normally associate with organic food were not significant in this particular occasion. So increasing or decreasing age, gender, education, or income were not significant predictors of our organic purchasing behaviour. Then looking at food waste itself, social norms were the most important aspect when it came to food waste behaviour. So if those around us disapproved of food waste or were less likely to waste food, we too were less likely to waste food. The behavioural control was also really important in this model. So knowing our knowledge of food waste and how to reduce food waste was really important in terms of ultimately reducing that behavior, the food waste behavior as well. Having the storage of our food and purchasing too much food or having food surplus in the house were also strong predictors of the food waste behavior. And age was also a strong predictor of food waste behavior. But the other sociodemic factors of gender, education, and income were not significant. So what I've just tried to do for the purpose of today's presentation is to give insights on how those findings might inform policies such as the Green Deal or campaigns to try and increase organic purchasing or campaigns to reduce food waste behaviour, how we might approach those based on the research. So in terms of the organic purchase behaviour, looking at the kind of traditional segments specific campaigns would not be recommended. So you don't necessarily want to target any of the demographics of men, women, higher, lower income, education, and so forth, because they in the Irish data at least, they don't appear to have any influence, and we'll see if this is replicated in the European data. What is important is to pay attention and focus on on the attitudes, trying to change the consumer's attitude to be more positive towards organic food, the societal norms. So if we're all purchasing organic food, if the important peers in our circle are purchasing organic food, we too are more likely to do that. And then our perceived control. So if you think, well, I can't eat organic food because there's none of it in the shop, I wouldn't know where to get it. And that's a really big predictor. So knowing that you have control over this particular behavior, and that if you wish to purchase organic food, it is there for you. So these are the aspects that we need to focus on to increase the purchase of organic foods. And then one of the other aspects is to enhance and emphasize the visibility or presence of these foods in the retail sector, so that it's obvious to the consumer to actually purchase it and put it in their shopping trolley. In terms of food waste behaviour, we need to focus on age and food waste as one of the demographics. So the lower age groups tended to waste more food. So we need to perhaps highlight that in some of the food waste campaigns. We also need to try and reduce the food surplus coming into the household by introducing more planning and more shopping lists when we're going for our shopping. There's a significant need, I suppose, to emphasize the value that we need to now place on food. It's gone from being one of the dearer commodities that we would have spent our income on to being one of the cheaper commodities. So we've lost value in our food in that regard. So we need to put back emphasis on the value of the commodity itself. And we can reduce that surplus by improving our meal planning and associated shopping lists then as well. One of the biggest findings in terms of food waste behaviour was our peer groups. And if our social peer groups are performing this behaviour, we're more likely to perform that behaviour as well. So promoting a positive behaviour and that control that we have to minimize food waste will have a big impact on overall reducing our food waste. So that's all that I have to say, and thank you to my contributors, Dr. Fiona Torn, Demetrius Brenikoff, Zane and Selena, for the analysis and contribution to this work, and the details are there, and I'll now hand over to Zane. Thank you.
Okay, thank you. Thank you, Sinead and Elizabeth. So I will share my screen. Do you see my screen?
Yep.
Okay, great. So let's start. Thank you again. So in circular agronomics, what I present are the farmer adoption result regarding the different innovations that were developed in circular agronomics project. And in fact, what we want is to analyze what would be the determinant factor affecting the decision of farmer to adopt the different innovation solution, practice, and innovation within the project. We focus on 4 case studies. The thermal solar dryers, fertigation with microfiltered slurry and digestate, low input farming, and precision feeding. For sure, I have only 5 minutes, so I will not explain the different innovation, but from circular agronomics, we'll be very happy. If you contact us, we can give you any additional information that you need about the different innovation. So what we did exactly, we made a questionnaire to farmers. It was not easy at all. In Spain, Austria, and Italy, in order to understand their behavior regarding the different innovation, we divide the questionnaire in 2 main parts. The common part that include farmer characteristics, structure management, attitude, opinion, environmental attitude, objective, social objective, economic objective, environmental objective at farm level. And we differentiate a specific part regarding innovation, where we present the innovation using different videos that were developed in the project and flyer, and explain main advantage and all the additional information regarding the technology that were developed in different work package along the project. So let's go directly to the main result that we obtained. Focusing on the specific innovation acceptance, we asked farmers about their opinion regarding the innovation proposed using different scales. It could be interesting, it's not very useful, it's not feasible, and it's too much work for little results. So what we obtained, a big share of answers were a big share of farmers consider that the innovation are interesting. So we said, perfect, we have the first client, we have the first customer. And the answer, no, wait, I said only that innovation are interesting. I didn't say that I will adopt it. And just for sure, they didn't say that. Just I want to share this with you to explain that the adoption procedure is not an easy task. It's very complicated and multidimensional aspect. And therefore, we ask them about their willingness to adopt innovation. As you can see, the percentage is totally different. In all cases, there is a relatively acceptable percentage whose answer yes or probably yes to adopt the different innovation and the different case study proposed. But the main question is, what would be the main factor affecting the decision to adopt or not to adopt? So let's first have a look about the main result regarding the different objective at farm level by farmer. As we expect, main importance is given to economic objective. We are talking about 70% of relative importance compared, for instance, socio-cultural is not at all important, with environmental receive 30%. And the main important aspect would be maximize net profit for them, increase sales, and diversify their production and marketing channel. And from the environmental point of view, the most important is rational use of water, maintain soil fertility, and reduce polluting emission. We analyze also their environmental attitude. Results show that are more ecocentric than anthropocentric. And also results showed very important point that there was a relationship between the potential adoption of innovation with being anthropocentric or highlighting anthropocentric attitude compared to ecocentric attitude. However, this individual relationship, it's not enough to really obtain more information about the factor affecting decision of adoption. So we made some modeling approach. And I would like just to focus on the main variables that are interesting to be commented. First of all, being a large farmer increased the probability of adopting innovation that were proposed in this study. Second point, toward more ecocentric attitude as expected, at least at what demonstrated by individual relationship. And if the farm is located in vulnerable area, increase the probability to adopt innovation. And if I'm not wrong, recently the classification of different regions in Europe was reformed by changing the limit of nitrate to classify region as vulnerable or not. So this was very important to increase the probability of adoption. And agriculture vocation training, if they had already adopted innovation in the last 10 years regarding environmental adoption of innovation to be more sustainable, let's say, and if they had agriculture university training by themselves or any member in their family. And for sure, the factor who decrease the probability of adopt is if they only trust family and friend information as a main source of information in their farm, and if they think that a big percentage of income should come from outside, from off-farm activity to ensure financial security. So lesson learned, I have just 1 minute. It's clear that there is need to economic support to implement innovation and emission mitigation practice. And this is not new. In fact, in the Common Agricultural Policy, there is in the Rural Development Support Scheme, the main different measure, the agri-environment commitment with respect to manure management, but also the most important that was highlighted, the investment into physical assets with respect to manure storage installation and anaerobic digester. Finally, 84% of farmers surveyed consider that institutions should encourage the implementation of new technology in agriculture, mainly through subsidy, but also through tax benefit in case of adopting this kind of innovation. This is what I want to present in the farmer study in the Circular Agronomic project. Thank you. I guess, Elizabeth, I can follow for the next presentation. It does not need to stop. It's open to
as you wish. If you want to take over now, otherwise, well, you can maybe then maybe I'll introduce the I'll introduce then the other project then.
Okay.
Okay, so now, okay, Zain will also present. He's also involved not only in circular agronomics, but he's also involved in Nitrate cycle. And so this project is focusing on closing nutrient loops in farm systems in the EU. And if I understood well, the whole food value chain is targeted in the project. And in particular, the focus is placed around 3 pillars: the agro-processing, the animal husbandry, and the plant processing. Nitrate cycle aims to establish innovative business cases at the pilot scale to act as lighthouses. So again, Zain will present for Nitrate cycle. I just explained his roles previously, but he will talk now about the role of the consumer preferences in helping to achieve more sustainable production strategy at the farm level. So Zain, the floor is yours again.
Thank you, Elizabeth. So before I explain farmer results in the Circular Agronomics project, and now I will explain the main outcome of the consumer preference result in the Nutri2Cycle project. Within the Nutri2Cycle project, we addressed a key question: is are consumer willingness to pay premium for food product that can be obtained through more sustainable farming system in terms of reducing carbon emission and optimizing the recovery of nutrients from circular farming by adopting some of the solutions that we propose in Nutri2Cycle project? And what are the perception and purchase intention and attitude toward this project? And what are the consumer perception regarding the value of agro-residue processing into renewable energy? So before going to comment a little bit what we did and the main result. So another important question that arises is why we should understand and why is important to analyze consumer preference. Our colleague before our presentation, Wim from DG Santé, he clearly explained that sustainability can reach not only at production level, but also at consumer level, retailer, and all the added value chain. So this is one of the main reasons, but also because while investing in the adoption of innovation, it's clear that an additional economic effort should be done at farm level in order to adopt this innovation. So it's important to know and to understand if this economic effort can be translated in some way to the market level by differentiating the price of this kind of product. We can talk later about which kind of label scheme that may contain. In similar way to organic food products. I mean, in organic food products, farmer may adopt their conventional system to be in organic production, and for sure they can be compensated in some way because price of organic at marketplace has this additional premium in the majority of the case. So what we did, we made a questionnaire survey in 6 European countries: Spain, Poland, Italy, Hungary, Croatia, and Belgium, reaching 5,600 consumers using the platform Qualtrics and the European Consumer Panel. And data were recently obtained, for sure, before the Ukrainian war, because as you know, oil prices has increased, and any results regarding paying a premium for sustainable label would be very complicated, but this was done before, so it's important to understand this is what a fixed photo of the situation. And we designed a questionnaire, and in this questionnaire we include willingness to pay question, food purchasing and sustainable behavior, food waste and recycling behavior, opinion toward impact of farming system on environment, environmental attitude, knowledge about farming, what they know, opinion toward innovation in agriculture, and concern regarding using organic fertilizer to produce fruit and vegetable. So for sure, I will not go to detail because I don't have enough time. I have just 10 minutes. So what is the main issue when you use questionnaire to ask consumer if they want to pay a premium? Because there is no consequence about the answer. There is a big bias in this kind of study when we ask consumer if they want to pay for a premium for ethical aspect or for environmental label. And this bias is a hypothetical bias because in survey, it's easy to find difference between what people say and what people do. And this is defined as difference between what the respondent indicate he would purchase and what he would actually do in real market. Just to take into consideration regarding the outcome, we will try to reduce the impact of hypothetical bias, but you will never be able to reduce it when you use hypothetical survey and just to be standard out regarding the main result that we explained briefly. We use 3 category of products: pork, milk, and bread, representing 3 main production systems in Europe: the big production, cattle, and cereal. And we use 3 different farming systems. And here we had a big challenge: how we should explain conventional farming without any negative connotation, how we should explain organic farming without any positive connotation, and what would be explaining circular farming. This is what our proposal to differentiate this new food product at marketplace. So we try to be as neutral as possible regarding the definition of conventional. For sure, I will not read it. But as you can see, livestock is housed generally under constantly controlled temperature. So we try to be as neutral as possible for conventional, for organic, and also for the definition of the circular farming. We used one of the definition by the FAO in 2004 regarding that their animal husbandry produce not only meat, milk, and egg, but also manure, urine, heat, ammonia, methane, and so on. And at the end of this definition, we identify the innovation of Nitrate cycle. In the case of pig farming, pig slurry and manure are treated to produce bioenergy and bio-based fertilizers. In the case of cattle, the dairy farm use wastewater to produce algae as a source of protein for animal feeding, and milk industry may use dairy processing residue to produce fertilizers. In the case of bread production, we say that cereal from flour are cultivated using crop management system that increase soil fertility, organic matter content, and cover crops and no-tiller practice. And we create different hypothetical market. We simulate different market in which we present in each purchase situation 3 products. First one obtained from conventional, from organic, and from circular farming. For sure, this purchase situation were repeated. Different combination of price were offered to consumer, and each country have its own vector of prices because we based our reference on organic products and on conventional products. So let's go to the main results. We ask them about what we perception regarding the impact on the environment of different farming system. And the main outcome that the circular farming was perceived as animal friendly, as environmentally friendly as the organic production system, which is positive result regarding the consumer perception about this kind of farming. And in some cases, for instance, in Spain, or it have a positive perception than the organic one. We asked them about the perception regarding the impact of diet on the environment. I know that we just explained the tendency of eating more fruit and vegetable and reduce meat product, and this was exactly what we obtained. In fact, if we focus on the flexitarian diet, that is reduce the quantity of red meat, results show that this diet was the most considered as more sustainable compared to vegetarian, vegans, and non-restricted one. We asked them if they do compost organic food waste. Results show that in Spain, big share, they said never, and the highest percentage was in Belgium, who answered yes, always they did it. And we asked them about if they have food left over, if they throw leftovers. And results show that in Croatia, Hungary, and Poland have the highest percentage, and the lowest percentage was in Italy, also in Spain, and in Belgium, less than 10%. And we asked them about the environmental attitude. In this case, we found that Belgium, Spain, and Poland were more anthropocentric than ecocentric compared to Italy, Hungary, and Croatia. And so sure, these are individual results for each variable independently. We asked them about what would be the innovation, what would be their opinion regarding different affirmation about the effort that government are doing to invest in agriculture to be more innovative and more sustainable. Results show that the majority agreed that government are not do not show enough interest to invest in research and innovation project in agriculture compared to other sector, in economic sector. They results also show that the important innovation for future of farming would be to reduce inorganic waste management and to produce bioenergy. It's important. Also, it's the same line of what we are analyzing in the different project in this session today. And we ask them about if they are concerned regarding the use of fresh manure to fertilize fruits and vegetables. And the questionnaire answer were that more or less they are somewhat confident. So it's important in this case to work on to increase consumer confidence regarding the use of the kind of fertilizers to produce fruit and vegetable. And let's go for the most important point, the main objective. Are consumer willingness to pay a premium for circular farming products that can be obtained from different innovation that we propose? The answer, yes, but it's not in all cases study. For instance, in Hungary and Croatia, we non-significant results were obtained. But I can say that in the majority of cases, yes, it was a premium in percentage term compared to conventional results. And we can talk about 28% as an average, about paying a premium compared to conventional products. And the value may range from 0% in the case of Hungary and Croatia to 40% in the case of Spain. But on average, we can talk about 30% premium for this kind of product compared to conventional product. Finally, if we want to focus on the lesson learned from this study, the price level of circular farming should be located more or less between 0 and 40% regarding conventional. It's important that this information may help retailer to define their marketing strategy and policy strategy regarding price. And for sure, we shouldn't forget the hypothetical bias, and we should extend this study to other product category and to other innovation to obtain more robust results regarding the premium to be paid for sustainable food product. Thank you.
Thank you, Zain. So we'll now hear from the Fertimanure project. As we've heard in the previous session, Fertimanure focuses on the development of technological approaches for nutrient recovery and manure management by producing a new generation of manure-based fertilizers. Fertimanure is also developing new business models to valorize manure resources and ensure their competitiveness in the market. And presenting for Fertimanure will be the project's coordinator, Laia Llenas Argelaguet. She's the Deputy Director of the Beta Technological Center at the University of Central University of Catalonia in Spain. And Laia holds a PhD in chemical engineering. She has a strong experience in waste and wastewater treatment and valorization technologies, which is mainly focused on nutrient recovery from different waste streams. She also has extensive knowledge and experience in the area of EU funding and project management. So Laia, whenever you're ready, the floor is yours.
Thank you very much, Elizabeth. I'm going to share my screen. Can you see the presentation?
Yes, yeah, everything perfect.
Great. So with this presentation, I'm aiming to briefly explain how Fertimanure project can provide policy relevant information with a special focus on the farm to fork strategy goals and considering livestock waste management as a key source for sustainable food production. So as it has been very well explained by Wim de Weckelaar, the farm to fork strategy aims to accelerate our transition to a sustainable food system. So one of the key elements of the farm to fork is to ensure a sustainable food production, and very summarized, some of the actions to achieve these are the ones shown in my slide, and are targeting the implementation of circular bio-based economy strategies to reduce the pesticides use, also reduce the excess of nutrients and the sales of antimicrobials for farmed animals and aquaculture, and also to increase the farmland under organic farming. So in this case, the Commission has established very ambitious goals to be achieved by 2030. So focusing on a Fertimanure project, the outputs obtained by our project are aiming to contribute to 3 of the 5 mentioned actions. So within Fertimanure, we will develop new circular bio-based economy strategies to promote bioeconomy among farmers. We will be providing new strategies to improve nutrient management and enhance nutrient recycling and a better use of the nutrients contained in livestock waste. And we are also aiming to see if our products could be accepted to be used in organic farming. So let's enter in more detail on the topic. So in Europe, manure is the largest waste stream rich in nutrients that could be valorized to recover bio-based fertilizers. And this is because the EU livestock sector is the largest in the world. So meat, milk, and eggs make up 40% of the EU's agricultural value, and it accounts for 48% of the total EU agricultural activity, with an estimated output value of 130 billion euros annually, and creates employment for almost 30 million of people. And it is estimated that total farm livestock population in Europe excrete around 1,400 million tons of manure every year. And this means that there's a total nitrogen and phosphorus excreted by livestock in EU around between 7 and 9 million of tons of nitrogen each year, and around 0.8 million of tons of phosphorus per year. And currently, more than 90% of the manure produced in Europe is currently returned to agricultural fields, either through the spreading of the collected manure or directly by grazing. So, in line with the goals of the Farm to Fork strategy, it is necessary to think about circular bio-based economy approaches. So the aim of Fertimanure is to consider manure management as a business opportunity. Here in the slide, I'm showing Fertimanure circular economy strategy. The first step will be to implement nutrient recovery technologies to obtain bio-based fertilizers from animal manure. And once the nutrients have been recovered, we are considering 3 possible strategies to be followed. First one is that the bio-based fertilizers obtained and recovered on farm can be directly used in the same farm or in the surrounding fields. Second option is that the bio-based fertilizers can be sold to the chemical industry in order to use them to produce tailor-made fertilizers with a high market value. And we understand a tailor-made fertilizer as a fertilizer specifically formulated to meet a specific crop requirements. Final strategy in this circular economy approach is to directly produce the tailor-made fertilizers directly on farm by mixing the animal manure with different supplements or additives. So the first approach targets a mixed farming system where nutrients can be directly used in the surrounding areas, whereas the second and the third strategies are better suited for specialized livestock farming, in which the nutrient excess must be exported from the region. So Fertimanure counts with a total of 5 pilots that are directly located in different farms from Spain, France, Germany, the Netherlands, and Belgium. And with these on-farm pilots, we are valorizing different types of animal manure, so including pig slurry, cow manure, and poultry. And with these pilots, we are obtaining a total of 19 different bio-based fertilizers, which I'm listing here in my slide. So the aim of our project is to see if these products can compete in the current fertilizers market. And for this, we will have different barriers. We have technical barriers, economic barriers, social barriers, but also policy-related barriers. And because this is, in this case, we are aiming to present possible policy recommendation. So I have been focusing on the political barriers that we have to enter these products into the market. So first and most important regulation to be considered in Fertimanure is the new fertilizing product regulation. And in that sense, Fertimanure will specifically consider the requirements established in this regulation to see which of our products can be CE marked considering the limitations of this regulation. So as a first step, we have been identifying the tentative product function categories fitting better with the 19 BBFs produced, as well as the potential component material categories. So then we have been creating an Excel file that will be completed with all the analysis required. And then hopefully at the end of the project, we will be able to see in which categories can we fit our products. So I will not enter into detail to this long list, but I wanted to mention that, for example, for the CMCs, CMC10 has been considered for all of our obtained products. However, we believe that there are other CMCs that are more specific and in which we think that after having applied a complete biorefinery process, such as the ones in Fertimanure, our products would fit better. And for example, we are considering CMC 13 and 14, which are currently written as an amended act of the regulation and hopefully will be soon part of it. But we are also considering CMC 15, which has not been officially approved yet. But with our project, we would like to provide relevant scientific data to demonstrate the quality of our products and also to help on going or improving this regulation. Another aspect that I wanted to mention in my presentation today is related with the organic farming. So as I mentioned in the beginning, the Commission will boost the development of EU organic farming area with the aim to achieve the 25% of total farmland under organic farming by 2030. The regulatory framework in this case has also been recently changed, and since January 2022, the new EU regulation 2018-848 has entered into force, and the list of allowed substances for organic fertilizers is regulated in the implementing regulation 2021-1165. The main limitation that Fertimanure products would have to be used for organic farming is that factory farming origin manure is forbidden to be used in organic farming. But it is also important to mention that in terms of quality, the products shall be in line with the new EU fertilizing product regulation, which we are already considering in the project, as I explained before. Having said that, I would like to make a small reflection. And for this, I'm listing here the reality of the EU livestock sector in the left and the organic farming targets and limitation in the right. By 2030, it is expected that the meat consumption and production will increase by an average of 1% each year. More than the 70% of animal farms are big farms, large farms, and this number in some countries such as Belgium or the Netherlands or Denmark reach the 90%. Moreover, there's a need to better manage animal manure and propose circular bio-based strategy, as manure is the main secondary source of nutrients, as I explained also before. And on the other side, we have that the Commission is also boosting the organic farming production, and nowadays organic farming accounts for 8.5% of the utilized agricultural area, but we have the objective that it could reach the 25% in 2030. So, in Fertimanure, we would like to provide policy-relevant information and technical guidance to demonstrate the safety and quality of our products, also for being used in organic farming. So in that sense, with our project, we would like to change the paradigm about the nutrients coming from animal manure, demonstrating that our bio-based fertilizers are not manure anymore. So in Fertimanure, a bio-based fertilizer is obtained through a physical, thermal, chemical, and or biological processes for the treatment of manure or digestate that results into a clear change in composition. So we highly believe that after a biorefinery, such as the ones developed in our project, the nutrients obtained are totally different than livestock waste. So we hope that, well, in our project, we will do different activities that we hope that can provide very useful information. So in that sense, we will be developing a complete sustainability assessment of the processes to obtain the bio-based fertilizers and the products and their application. We will also do a quality and safety check of the 19 BBFs considering the new regulation. Also, a thorough evaluation of antibiotic-resistant genes and their dynamics when the BBFs are applied will be done. And we will be comparing our products with raw manure and with other commercial fertilizing products. So hopefully, our project results will help on changing the perception of nutrients coming from animal manure and overcoming the current political barriers that may hamper its application. So thank you very much.
Thank you, Laia. So we'll now move to the final presentation. This one will be from the Lex4Bio project. This project started in 2019 and will run until 2024. Lex4Bio is looking to reduce the dependency on mineral phosphorus and nitrogen fertilizers by increasing the production and uptake of bio-based fertilizers. Lex4Bio works on several fronts, from providing the knowledge to develop these bio-based fertilizers to also creating the policy framework that allows their safe development and use. So speaking for Lex4Bio, we have the project coordinator, Kari Ylivanio. He's a senior scientist at the Natural Resources Institute in Finland, the LUK. And Kari holds a PhD in environmental soil science, and his work focuses on plant nutrition and related processes in soils, especially on the optimization of phosphorus fertilization in crop production. Kari will talk about reducing nitrogen and phosphorus losses, taking into account the farmer and the consumer perspectives. The floor is yours, Kari.
Thank you. I will share my screen. Are you able to see the whole screen?
Yes, we see it.
Okay. So I will present here some preliminary data from Lex4Bio that support the goals of farm to fork strategy and some perspective from farmers and consumers' point of view as well. So as said earlier, farm to fork strategy aims to reduce nutrient losses by 50%, and this is assumed to lead 20% reduction in fertilizer use by the year 2030. In order to reach this target, fertilization needs to be optimized according to crop requirement under different climatic and soil conditions in the EU. And in Lex4Bio, we are especially concentrating on bio-based fertilizers, which originates from nutrient-rich side streams. And the main side streams are animal byproducts, especially manures, and then sewage sludges. And these side streams, of course, they are mainly regionally concentrated, and this can be seen, for example, as a legacy phosphorus concentration in agricultural soils as an increased P content, and also as a nitrogen losses. And of course, for reaching this circular economy, it requires better utilization of these side streams and turning them into bio-based fertilizers. As said, Lex4Bio aims to optimize the use of PPFs and also at the same time ensuring agronomic efficiency, food and feed safety, human health, and environmental protection. For reducing phosphorus losses, the first thing is to know the bioavailable phosphorus concentration in agricultural soils, because this determines how much we are actually needing phosphorus fertilizers. And this is commonly done with different soil testing methods, and there exist several different methods across European Union. So the comparison among countries, for example, these fertilizer recommendations, it's quite complicated. So this figure shows the first preliminary data of our analysis, and it just clearly shows that there are areas where soil phosphorus status is so high that there is no need for phosphorus fertilization at all, whereas in some regions soil phosphorus status is much lower. As compared to mineral fertilizers, these bio-based fertilizers, their properties varies quite a lot. There's fertilizers that can have a high organic matter content, whereas some fertilizers resembles quite a lot about mineral fertilizers. And when considering these different climatic conditions and soil properties across Europe, these bio-based fertilizers should be used in areas where we can get most out of them, for example, when considering soil organic matter content. So as a recommendation, these fertilization needs need to be adjusted according to crop requirement, taking into account different growing conditions. Then with nitrogen, if we want to reduce nitrogen losses, we need to improve crop nitrogen utilization efficiency. And when reducing losses, we need to have a better knowledge about the characteristics of these bio-based fertilizers, as well as soil properties, in order for us to adapt suitable fertilizer application methods. These figures also shows some conceptual data from the data what we have observed so far. It just shows different nitrogen-based fertilizers and how this nitrogen mineralization varies depending on the source of nitrogen. Here we have a 50 days period, and it shows that this mineralization, nitrogen mineralization varies from down to 20% up to 80% of the total nitrogen during this time period. So there's a great temporal variation in this nitrogen mineralization. And also this potential ammonia volatilization differs a lot between different fertilizers. So because of this, application of these nitrogen-based fertilizers, applications with high ammonium content or rapid nitrogen mineralization should preferably be incorporated into the soil quickly in order to minimize the risk of significant ammonia losses. Let me see now. Okay. And in order to utilize these fertilizers efficiently, we need to know the knowledge about the agronomic efficiency and risks for environmental losses. And for this, we have different kind of compliance tests, which are commonly conducted in laboratory. And our field and greenhouse trials has shown that this agronomic efficiency varies there's a great variation among BBFs, and nutrient and harmful heavy metal losses are also affected by the soil properties. So this compliance testing of bio-based fertilizers needs to indicate agronomic efficiency, both nitrogen and phosphorus, of course, and potential environmental emissions, for example, ammonia volatilization or phosphorus leaching. From let me see, change the slide. From a farmer's perspective, these bio-based fertilizers may provide a viable alternative source of plant nutrients and reduce dependency on mineral fertilizers. Many of these fertilizers provide reasonably high crop nutrient use efficiency, but nutrient availability, release pattern, and risk for nutrient losses varies more between BBFs than for mineral fertilizers. And this then requires better compliance testing and also follow-up of nutrient demand by the individual crop during the growing season. Also, farmers should determine the nutrient content of these BBFs, especially of these bulky materials, which are especially these liquid and moist fertilizers, before application, because this allows more targeted use and minimizes nutrient losses. When considering the storage, some of these PPFs, especially these liquid and moist samples, they need different storage conditions than mineral fertilizers in order to conserve the quality and avoid environmental impacts. Many of these fertilizers can be applied with existing fertilizer spreaders, but these bulky materials may require alternative spreading equipment, because the amount of fertilizers that will be spread is much higher compared to, let's say, mineral fertilizers. From a consumer's point of view, these fertilizers provide alternative and often local fertilizers for farmers, and this may ensure both better food security and a more circular economy as well. Provided that these fertilizers fulfill EU and national criteria for application in certified organic production, they may contribute to an increased area cultivated in organic farming. And many of these PPFs have similar or lower trace metal contents as compared to mineral fertilizers, and therefore their use does not threaten food quality or soil metal accumulation. However, there are some critical trace metals and other contaminants that needs to be taken into account and closely monitored and regulated. Thank you.
Thank you, Kari. So now we have finished the presentations. We've seen different ways of addressing the farm to fork objectives. I see there's not many questions here for the Q&A. There's one directed, so please do write them now if you have any. Otherwise, I'll go ahead. There's one for Wim Bekele. What do you see as the main challenge for farmers to reduce nutrient losses?
Yeah, well, thank you, and it's a very good question, but I mean, we should not blame it on the farmers. First of all, I think the farmers, they do what they can do within the, let's say, the resources and the possibilities that they have. I think, indeed, there's still a lot of possibilities to reduce nutrient losses, and that's why, in fact, this in the Nitrate Directive and these action plans have to be established by the member states and then have to be implemented. So the nitrate action plans, and they have to be implemented by the farmers indeed, and they have to be applied by the farmers. But I think, in my view, a main role is here for the authorities to make sure that the necessary measures are provided or required, that there is a level playing field between farmers, between member states as well. There's a lot of things that still could be done, and because we see that but it's not up to me here to provide all these answers. But yes, you have a possibility to put catch crops, to have the crops which are leaching and things like that, to have restriction, more closed periods. So there are a lot of things that can be done. And by the way, here also these projects also provide additional information and additional things that can be done. So yes, there's a lot of things to be done, but clearly I would say it is not the farmers are also a bit the victim of the farming system. So if things are not going well for the environment and nutrients get lost, it is the system which is here at the question. So it's not the farmers, I would say. Yes, and they are indeed, depending on the advices that they get, on the legal requirements, and also they are need to take into account their economic situation. So I'm probably not giving let's say a straightforward answer to this, but there's a lot that still can be done for sure. But not only the farmer have to come with the solutions.
No, I'm aware that it's a complex issue. And we have a second question for you. I get that you're probably getting this one quite a lot these days. It says there's a risk that the current issues in food supply due to the Ukraine war will significantly reduce the ambition of the farm to fork goals. Well, it's a question. I don't know if you want to reply to that.
Well, I mean, yes, there is some let's say issues probably at short term which would need to be and the Commission is considering that. But I think that this crisis with Ukraine and any other crises that will come and that have already there, and we have the climate crisis, so many other crises, and again they confirm the need to have a system in place which is sustainable. So I think this is for me personally then, and I think for the Commission as well, a confirmation to have a more sustainable system in place where we are less depending on imports of feeds and things like that. So where we really are more sustainable, doing and using more recycled nutrients and so on. So the Ukraine crisis, it's very unfortunate, but it confirms the need of a farm-to-fork system.
Indeed, yes. And linked to this, I had a question for Zain, actually, because in your first presentation, you mentioned that farmers' attitude, when we talk about farmers and what they can do, you said that the attitude towards the environment was key to adopt the proposed innovations. And I'm wondering if in your research, you're also taking that second step and looking at ways, exploring ways through which these attitudes could be changed. Or are there any elements in your research that, that help you take that second step, say, to address the issue?
In fact, we're still analyzing the data. I see, as you see, it is not. It is very complicated concept analyzing the adoption process at farm level, in particular where the main innovation are not 100% scaled at farm level. And one of the main questions that we received, Elizabeth, is that they want to see them. It's not enough to see them in the video when they're not able to see them, and it's not able just to see about their advantage. And one of the aspects that we note that they want first to see a farmer that first adopt this innovation. Once it adopted, so they can see that is one of their communities are already adopting the innovation, and this can create a confidence. So the main important is the first step of adoption. And we did not go we did not go enough in deep in order to analyze more things about attitude, but we're still working on the analysis.
Mm-hmm. Thank you. Thanks for that. And I also had a question for Laia on fertility, because the project is working, I understood from the map that you showed, on the more intensive livestock dense areas in the EU, which makes sense for fertility manure. And I was wondering, are you in touch also with regional governments or farmer organizations to test exactly, well, to see if the innovations that you're proposing, well, you talked about the general policy framework, but is this only at the EU level to make sure that there's a level playing field between countries, or is it also, they also do some kind of work in the regions?
Yes, so in terms of legislation and regulation, we are considering both levels. So we are considering the EU framework, as I explained today, but we are also considering all the member states' regulation to see which limitations do we have at member state level, but also at EU level. So to see which limitation we would have to apply and to use our products at both levels. So we are considering both. And in fact, in the project, we have also the public administration involved as project partners, at least at Catalan level and also at French level. And we are in touch with them. And we are also organizing different workshops to consider it.
Okay, thank you very much. So I'll just give final occasion for anybody who wants to ask a question. Otherwise, we will be closing the session. Well, there's no one else. Then I think, well, we reached the end of the session. I think we saw that there are many different ways being explored through which the farm-to-fork objectives can be achieved. Of course, many challenges remain on implementing many of these changes on the farmer side, but also in terms of aligning the policy framework and making the message reach the consumers. But well, it's been clear today that we need everybody in the food chain engaged. And I want to thank the speakers that we had for this session for their input and engagement. Also the BioRefine cluster team for the smooth running of the webinar, and to all of you who attended for your interest in this event. And I leave the word now, I'll pass the word to Eric Mears for the final closing of this Esni event.
Yes, and thank you. And this brings our edition of Esni to the conclusion. So I would like to thank, of course, Elisabeth Nadeau for the excellent moderation of the second session as well. I hope that all of you found it a very interesting program. At least I found it very interesting with all new topics and old topics and running topics in both sessions. So I think it was, again, a very lively and dynamic event. We are also hopeful that next time we can meet up physically in Brussels, but let's see how that progresses. Keep following us on the BioRefine website and the social media. You can also contact us for getting those monthly BioRefine bulletin updates if you wish to follow the projects. And with that, on that note, I would like to conclude this session and this edition of Esni. Thank you very much for attending. And maybe one last notion I have seen in the chat. Of course, indeed, the presentations will be made available as well as the recording. So on that practical note, I wish to say you farewell and see you next time.